So weatherbench, the specific application is actually to make global weather predictions. How does it work? What is the data behind weatherbench? The data is what we call a reanalysis data. So what's happening in reanalysis data is that people at Copernicus and EUMETSAT, they're actually generating a reanalysis product by using a lot of observations from the past, and actually the past, I mean a couple of decades into the past. And then they continuously do a data simulation process using the observations and the weather forecast model, bringing them together, and then basically generating a trajectory of the weather forecast model that is as close as possible to the observations. And that's very consistent over the entire period of time because it's using the same model and the same data simulation framework. What you can do now is you can actually try to learn the update from one time step to the next using machine learning. So you can literally just try to understand how you can predict a very short period of time into the future, for example, 6 hours or 12 hours or a day. And then once you've done this, once you kind of have learned how to predict into the future for a specific time period, you can actually make predictions. So if I would give you now the same reanalysis product for today, then you could literally just run your machine learning tool and you could look into the future. So you can literally make a global weather prediction with this. So that's quite a nice thing to work on in principle, right? It's kind of quite satisfying to actually generate a tool that could potentially predict the weather into the future on a global scale and just based on a couple of 100 lines of Python code. So is a weatherbench dataset actually useful? Are the predictions kind of competitive with operational models? This kind of idea of basically building weather type prediction models purely based on machine learning is very interesting for what we call nowcasting. So if you just look into 1 hour into the future, for example, those machine learning tools are extremely efficient and therefore they are very competitive on the very short time scales. However, if you talk about weather predictions that look a couple of days into the future, the weatherbench type models, they don't have the complexity of a really operational weather prediction system that like we would run, for example, at EUMETSAT. So our systems have billions of degrees of freedoms when they want to run, for example, 15 days into the future. And weatherbench type models have kind of orders of magnitudes less complexity, basically, because we have an enormous amount of data in terms of volume to train from, but we only have something like 40 years available, or 50 years maybe, in terms of satellite observation. And this means that we don't really have a lot of very independent weather situations that you could train from in terms of the observation space, sufficient to actually train a model which is as complex as our weather prediction system based on conventional methods. So these weatherbench type models are not really competitive for operational weather predictions a couple of days into the future. However, they're actually quite good. So given that the first papers have been published on this in 2018, it's quite impressive how much progress we get for those weatherbench type models, and there are more models coming up over the time. So it's kind of a very active area of research as well.